Hello and welcome back, guys. Today we shall take for the first step towards assembly language programming in 885. It sounds cool, right? Yeah. So today we shall teach you the first set of instructions, that is a data transfer group of instruction. We shall cover 19 fundamental instructions very useful in 885 programming. Before that, if you are new to this channel, please subscribe and press the bell icon down below because we release videos on cool engineering topics every damn week. So please subscribe and press the notification bell to get notified at right time. So without further ado, let's jump right into it. So before everything, remember these following facts. In 885 programming, the address is always happens to be 16-bit. The data in memory location and each general purpose register is always 8-bit in size. When we are dealing with register pairs, then we are talking about 16-bit data. So let's get started with our first instruction, that is MOV A, B. This instruction MOV stands for move data. So this instruction particularly is responsible for copying the content of B register into the A register. So people get confused here. Why? Because they cannot remember that whether the content of A gets copied and pasted in B or the reverse is happening. Get it clear for one and all. I'm sure that if you have come to learn 885 programming, you have definitely done some programming exercise in C language at least. So what you do in C or any other goddamn language in the world, when you have to copy the content of B variable into A variable, what you write? You write A equals to B, right? So you write the destination first and then the source. So here B register is the source and A is the destination. So when you write MOV A, B, then the content of B gets copied into A. Okay? Let's move on. The next instruction is MOV A, M. So this instruction is very, very important as it introduces a new concept of memory pointer. I hope you have watched the architecture video, and I'm sure that there you haven't come across any physical register called M. Okay, so what is M? Always remember that whenever 885 MUP comes across such an instruction where M is present in the operand, it first goes to the HL pair and finds out what it is storing. Okay, so let's say HL pair is storing the value of 3000 hex presently. So MUP goes to the location 3000 in the memory and sees whatever content it is holding. So it seems like the memory location 3000 is having a value of 61 hex. So the MUP takes this value, whatever is present here, and puts it in the M register so that the programmer can access this register. This is not a physical register, therefore you know, and it is definitely a virtual register. So what does this instruction do? It simply copies the content of M into A. The content of M is 61, so that data gets copied in the A register. Next instruction is MOV M, A. You can definitely guess what this instruction does, right? It does just the opposite of this. First, it goes to the register pair HL, finds out whatever memory location it is pointing towards, takes the content of A register, that is the accumulator, and pastes the content within that location. Next instruction is MVI A, 25x. Now in here you haven't come across an operand, that is a data itself. So whenever you see a data in the instruction, don't jump right into a conclusion. It may be an address or a data. So whenever you come across a number in the instruction, search for an I in the mnemonic. This is the mnemonic. So here you can see an I in here. So what does I signify? Wherever you can find an I here in the instruction, then you can easily conclude that this number happens to be a data, not an address. So what does this mnemonic stand for? This mnemonic stands for move immediately into A. Okay, so what happens is this data 25x gets copied into accumulator. Am I clear? Next instruction, MVI M, 25x. You can easily guess what is going to happen, right? The MUP will first go to the HL pair, see whatever memory location it is pointing to and write this data in that location. Very simple. Let's move on. Next instruction is LXID. LXI stands for load immediately, and this X signifies that here is some sort of register pair involved. So always remember this critical fact that whenever you come across a I in the instruction, that signifies that in the operand there should be some sort of data, and whenever you come across this X, that means you have a register pair involved in that instruction. So here you can see D, that means the register pair DE is involved. You need not write DE, only D gives the job done because D cannot pair with any other register but E itself. So what does this instruction do? It simply copies 1600 in the register pair DE. So as you can see that the higher byte 16 goes in D and the lower byte 00 goes in E. Next instruction is LDA 1600 hex. LDA stands for load accumulator. Okay, LD for load and A stands for accumulator. So here you can again see some sort of number, and here you cannot find an I. So what does it signify? This is not data but an address, right? So in here in memory somewhere this memory location 1600 is present. MUP will simply take whatever the content of 1600 is and put it into A register, that is the accumulator. Let's move on. The next instruction is STA 2000 hex. This does just the opposite job of LDA. STA stands for store accumulator. That means the content of accumulator has to be stored somewhere where the address is given in here, that is the 2000. So in here in the memory location of 2000, say some arbitrary value F5 was present. So MUP will simply copy the content of accumulator in here. That's it. Next instruction is LHLD 3000X. Now this is a simple tricky one. Okay. Now as I have already told you that whenever you come across a number, you should search for an I in the instruction. But here you cannot find an I. So you can clearly conclude that this 3000 hex, this is an address, not a data. So if it is an address and it happens to be 16-bit, it is very often mistaken that the content of HL is going to be 3000 hex, but it is not the case. Say if you had an objective to load the HL pair with the value of 3000 hex, you would simply do LXIH 3000 hex. That would do the job, right? But if LHLD is a separate instruction that LXI, then it has to be something different. So what it does, it simply loads HL pair, but not with the value 3000, but from an address 3000 and the consecutive address. That is, the content of 3000, the lower address, is going to be written in here in L register, and the content of this higher memory location is going to be stored in H register. I suppose from there itself the register is called H and L. That signifies simply high and low. That is, H carries a higher byte and L carries a lower byte. Next instruction is SHLD 3000 hex. This simply does just the opposite job of LHLD. That is, A stands for store. So you have to store the content of HL in the memory location 3000 and the consecutive location. So the MUP stores the content of H register in the higher address and the content of L register in the lower address. So now comes the trickiest ones. LDAX-B. Though these are very simple, I will hopefully make you understand the whole of it. LDAX-B. So from the previous knowledge you can see that LDA is present already here. So you have to load the accumulator, and X is also present, so that means some sort of register pair is involved in here. So If you can see B here, that means this B is not only B but BC registered pair. So what does it do? Let's get clear. In here in BC pair, suppose the value 3000 is present. So the MUP will go to the location 3000, copy the content of that location and paste in the accumulator. Next instruction is tax B. That again signifies that STA you have already come across. That means you have to store the value of accumulator somewhere. X signifies some sort of register pair, and as you can see B in here, that means BC register pair is involved. So the MUPIC goes to the BC register pair first, sees whatever memory location it is pointing to, comes to that memory location and copies the content of accumulator in here. Next instruction is PCHL. So what does PCHL do? The instruction PCHL simply copies the content of HL pair into PC, that is the program counter. I hope you remember the architecture video, right? PC stands for program counter. So the content of HL register pair goes into PC. Suppose this is your memory, some arbitrary block of memory, and currently PC, the program counter, is pointing to this arbitrary memory location 4753 hex, and hence the content of this particular memory location has to be fetched, decoded and executed by the MUP. Suppose in here you have some sort of data like E9, and for your information let me tell you that E9 happens to be the opcode for PCHL. Okay, certainly this is in its binary form, that is a 8-bit binary form, but for the cleanliness I have written E9 here. Okay, so E9 has to be fetched, decoded and executed as I have stated earlier. So in here in HL pair, suppose 4758 hex is here. Okay, while the process of decoding was going on, I hope you remember that the PC has to point to the next memory location. Now as soon as the execution of this particular command has been done, the content of HL gets copied into the program counter and the program counter simply jumps to this location. Okay, this could be anywhere, here, wherever. PC had to jump to this memory location pointed by HL pair. Next instruction is SPHL. So this is quite obvious that it is simply like the previous instruction PCHL. The content of HL register pair is going to be copied in SP, that is the stack pointer. So here you have the HL pair and here you have SP. The content of HL is going to be copied and pasted in stack pointer. Next instruction is Xchg. This is the exchange instruction, and as you have seen the architecture video, you already know that this instruction simply exchanges the content of D register pair and H register pair. So let's see the process once more. So this is what happens. I've already explained you. So let's move on to the next instruction. This is XTHL. To understand this instruction, we have to first understand what does it mean. XTHL simply means exchange top of stack with HL. So in here again you have some sort of exchange kind of instruction. So if you have to exchange something, you should have some kind of placeholders. So you have to deal with 16-bit data no matter what. So you have to use a 16-bit placeholder, then that is going to be WZ again. So let's see what happens. Here is your SP pointing to this particular location. That means this is your top of the stack, and this particular location is SP+1, that is the consecutive memory location. This is your Z and W register, and this is your HL pair. The first step is the top two elements of this stack gets copied into Z and W register, and definitely the rule has to be followed that the content of the higher address has to be copied in W and the content of lower address has to be copied in Z. Then step number 2, the contents of HL pair has to be copied in here. Higher address higher byte, lower address, lower byte. And then the last step, that is the contents of WZ gets copied in here in HL pair. I hope this much is clear. This is a chunk of information, but I hope that you have got whatever I am trying to explain. Now, so let's wrap up this big chunk of information, and the takeaway from this whole video is the whole video along with a simple information that none of the flags of the flag register, I hope you remember, those flags are never ever affected by any of these instructions, because flags are only affected when there is an ALU operation involved in it. But in here, so far I have talked about 19 instructions, but in any of them I haven't discussed about any kind of ALU operation. So the flags are not disturbed while executing any of these operations. Hope you guys like this video. Let me know your feedback down below at the comment box. And if you wish, like, share and subscribe. It's really encouraging. See you in the next video where we shall cover the arithmetic set of instructions. Take care. Bye.